How many of you are graduating this semester?
Sounds like none of us.
None of us.
There's some people who do graduate mid-year, you know.
Do you check you off on the paper?
Huh?
I appreciate that very much.
All right, calculate the biasing conditions and do the game. I hope this is not difficult for you at this stage of the time, all right? So what's the equation for the current? Right? This is it. Okay, what did I say? So for the voltage, not the current, it's easier. Let's start with the voltage. Here's VG. What's the value of VG? 6 volts, right? What's the value of VS? 3K times IDS, right? So what's VGS then? The difference, right? 6 minus 3K IDS, and from here you can get IDS. And then write it down. 1 milliamp per volt squared, VGS minus 2 squared. Right? That's that equation. 3 times, so you're going to have 6 minus VGS equal to 3. VGS squared minus 2 VGS minus 4 VGS plus 4. So you'll have 3 VGS squared, 12 minus 11 VGS, 12 minus 6 equals 0. Right? Plus 6. And let's see if this factors. 3 VGS, VGS. So that would be minus minus, is that, or minus plus? Minus minus, is it 3 times 2? Would that work? Would that work?
Yeah.
3, 2. So you have a choice now. VGS equal to 3 or 2 volt.
3.
3 or 2.
Minus VT is 2. Yeah, that would be 3. Because 2 minus 2 would be 0.
Yeah, but,
Almost 2/3, I think.
oh, not 3.
2/3 for the
2 over 3.
Oh,
And then you have 3.
The other one's 3.
So,
Yeah.
The other one, 3, Scott was trying
this one 3?
to, yeah.
Yeah.
And then you was
Oh,
shooting for
3,
3
yeah.
because grade was 1.
So VGS equal 3. So I sub D is equal to what? We already have it here. 6 minus 3 divided by 3. Beautiful, right? Watch me not doing that on the final.
Yeah, I'll take another curve.
Then you start scratching your head. I don't guarantee that, okay, but, okay. So this is 1 milliamp, and you have to put VDS. What's VDS? What's VD?
10 minus 4K
6
times.
volts.
6 volt, right? What's VS? 3 volt, right? Current is 1 milliamp. So VDS is 3.
Yep.
Okay, this is 6 volt. Now I remember. I remember.
Is on plan.
What's this voltage?
Which one?
That's a problem I made where the number doesn't come out.
Yeah.
Okay.
Yeah, that's one.
Look, the clue is here, 5.3. When I was designing the problem,
You wanted 1 milliamp? and
I
you
wanted
didn't get
1 milliamp, but when I designed the problem,
it's
I put 5.3 here. I should have put
6.7.
6 plus 7K.
Yeah.
Yep.
6.7.
That makes sense.
It would change the problem, but I put 5.3. I thought it was,
1 milliamp.
but it's correct problem, I mean, so, you wanna make 1 milliamp,
Sure.
Yes.
Change it.
Yes, please.
okay? It'll be different than the book, but that's the same
Okay.
thing, right?
More
I hope it
practice.
still works, because I don't wanna push it into the non-linear region. I mean, this has to stay in linear. Well, let's see. If you get 1 milliamp, if I put here 6.3, yeah, it's still,
4.3.
see, this has to be higher than 6,
Has to be 3.3.
Right.
K.
huh?
I think it has to be 3.3 K resistance.
What'd you say?
I think the resistance has to be 3.3 K.
3.3?
Yeah, and then the voltage drop, if it's 1 milliamp, will be to 6.7 volts from 10 to 6.7.
Oh, yeah.
Oh. Oh, there's a 10 volt here.
Yeah. So it should be.
If I should put 3.3,
The 1 milliamp.
okay, 6 minus 6.7, it'd be 3.3, right? Now, see, there's a 10 volt here. So this would be, this voltage would be 6.7 volt, and the current will be 10 minus, it'll be 1 milliamp. Ignoring base current, 1 volt. Now this is P channel. Let's see if it's still in the linear region. This diode is on. Remember, there's a diode. This is P and P, and there's a diode this way. Is this diode off? It has to be off, right? For a linear region. It is off. This is 1 volt. This is 6. So it holds. So now we got I sub C, the Q2, VCE, I sub C. It's not VCE, it's VEC. Right?
VEC,
VEC,
yeah.
because it's P channel. This could be what? VEC. E. Emitter is at 6.7 and the collector is at 1, so it's 5.7, 1 million. Since we got here, let's calculate G sub m for this one. G sub m1 is equal to 2K N VGS minus VT. So that would be 2, and K is 1 milliamp per volt squared. VGS we solved is 3 minus VT is
It's 2.
2. So the answer here is 2 milliamp per volt. Okay? Here you can calculate R pi if beta is 100 or little RE, depends. R pi will be 2.5K. Little RE is equal to 25 ohms. You could do T model if you need little RE with T model, but this is easier to do with the pi model. Okay, drawing the AC pi model, gate, source, drain. Oh, yeah, there's a current source. What the source is sitting at? It's ground, right? The 3K is shorted, so there's a ground, and this is up here. This is VGS. At the input, you got 6K in parallel
2.4.
with 4K is 2.4K. And here's Vn. Now, the drain has 4K, the ground, right? And then you go on the base, emitter, and collector. And from the base to the emitter, there's R pi. Don't forget those. And here you have beta IB. And this is IB. And where's the emitter at? Huh?
The current goes up.
The current is up. Where's the emitter at? You see that capacitor? That's a simple problem. And what is tied on the collector is 1K. Right? So A sub V, V out over V in is equal V out over IB, IB, this is G sub M VGS. Over VGS, over VGS, VGS over Vn. V out over IB is beta 1K, right, plus. What's IB over G sub M VGS? That one. Minus G sub M, 1, is current division, right? 4K divided by 4K plus R pi, which is 2.5K. Right? This is 2.5K. That's current division. And what is this one? No, this one. 1. Okay, let's put the numbers in. What's number? Beta, let's say 100 times 1K, G sub M, 2 milliamp per volt, times 4 over 4, 6.5. See the K goes out with the middle. So 200 times 4, 800 over 6.5. The gain comes from the BJT. And did we get the right? Yeah, minus.
Negative 123.
What?
Negative 123.
All right. Suppose this is I out. I'm just adding a little bit more stuff. And this is I in. Find the current gain. AI equal I out over I in. You don't need to do all this. How? What's I out equal to? Take a look here. It's V out over
1K.
V out over 1K, right? So that would be V out over 1K. What's I in?
RDS.
V in over 2.4.
V in over 2.4K. So this would be V out over V in times 2.4 over 1. Right? So this would be minus 122 times 2.4. Because this one is minus. Right? Minus 1. What's that number?
Negative 295.
Negative 295.
295.2.
How about A power? Power gain.
That would be the current gain times the voltage gain.
122 times negative 295. It's positive,
Yeah.
right? It's positive. Power gain, you're gaining power.
35,990.
9 what?
35990. Nine nine zero. Not 35.
Kilowatt per watt.
Yeah.
Okay. So this is not really a major thing. Now you know both transistors, you know their pi model. You could finish them. So really, any questions that you have missed, or you have something you need to know? You want to see a three stage?
Yeah.
I don't know.
You like to see it?
I don't know. 3 stage.
Let's do three.
Three-stage amplifier.
But
Sounds like fun.
yeah, it is fun.
So is that a preamp and a
Uh,
post amp?
A three-stage amplifier. Let's see what this does.
Okay.
It's not easy to design these, by the way. As a problem to me, but to get all the numbers to work. Here I added one more thing. I think it's 1.2K. Yeah. Now I need it. Can. KP. Well, the rest, ignoring out, and beta is equal 100. Solve this problem. Where do we start?
Let's start base voltage.
Okay,
4 volts.
4 volt,
Mm-hmm.
and, oh. I think it's 5.3K now. I think. Yeah. Let's see what the, I hope the current is. I don't want messy currents.
I will dial in there. I will pop and buffer. These guys. These guys. It's gonna be. You can put it in the phone.
Yeah, 5.3. All right. You told me this is 4 volt, right? This would be 4.7,
Mm-hmm.
right? What's the current on the one? 1 milliamp, right? This is 1 milliamp.
Oh, yeah.
If this is 1 milliamp, what's the voltage here?
2.
2 volt. Now you got some work to do to get this one, right? Because you got the solve quadratic equation. So VG is 2 volt. VS is, ignoring base current by the way, we're ignoring base current.
Isn't VS on top?
I'm sorry?
Isn't VS on top because of PMOS? It's a PMOS, right?
That's a PMOS, yeah.
Yeah, so wouldn't that be VS then? It would be 10 minus 5K? Or 10
No,
minus?
no, no, I'm not done there. I'm here still.
Oh, okay.
VS is what? Oh,
Yeah.
okay. What is VS? 10 minus
5K times
IDS
IDS times 5K.
times 5K. Now, what is VSG? That's what you have to solve for, right? It says P channel. VSG would be 10 minus IDS 5K minus 2, so that'd be 8 minus 5K IDS. This is VSG, not IDS, ISD. That. Now you can get ISD it'll be 8 minus VSG over 5K. That's equal to KP. KP 0.25, right? Milliamp per volt times VSG minus
Yeah, absolutely.
absolute value minus 1 squared that. Let's see, can we normalize this so I don't have to do fractions? I'm sure the numbers will come out nice.
Multiply both sides by 10.
Okay. If I multiply top and bottom by 5, it's not gonna help anyway. 8 minus VSG, 1.25, VSG squared minus 2 VSG plus 1. 1.25 VSG squared by 2 times this one. How much is that? Then plus 1. Two, that's 2.5 plus 1 minus 1.5, right?
Oh, yeah.
5 VSG, and this is only 1.25 plus, it'll be 6.75 equals 0. Right? Solve that later. This is a funny looking one.
Negative 1.8 and 3.
2 what?
Negative 1.8 and 3.
It can't be negative.
So that's 2.
There you go.
It's gonna be 3, yeah. 3.
You get 3 volt.
Yeah.
See, I knew this should come out nice. 3 volt, look at that, look at that. So ISD is equal to 8 minus 3 over 3K, 1 milliamp. Okay. Now we got 1 milliamp. What is this voltage? What is this voltage?
2K times 1, so it's
It's a volt, right?
About 2 volts,
Beautiful. What's this current voltage?
1.3, yeah.
What's this current?
1, maybe 10, so
Beautiful, right?
Yeah.
Okay, we need G sub M here. G sub M for this one is equal 2K P VSG minus 1 no square. I took the derivative. So 2KP, I don't know, okay, there it is. So it's, I can't wait till December 7th. Day that lives in infamy.
Is that when the enrollment period ends?
Medicare sign up will be over.
Yes.
Isn't that something? It'll be 3 minus 1,
We're gonna sign next year's for you.
so there'll be 2, will be 1
We
milliamp
didn't sign this year. Sign next year.
per volt.
For 6 months, I think.
You should answer, thank you for calling the FBI fraud.
Oh my, I've answered many different, custom out in Arabic.
They don't care.
I mean,
That's classy.
but it's a computer, and
It's
one
robo
time,
dial-in, and then they connect you with an operator.
it's Sarah or Denise, and then they started getting mail names. And then I answered 2-3 times, you get, I guarantee you they're overseas, because you get people with very heavy accent.
Yeah.
From Far East. You can't understand a word they're saying anyway.
Right.
Then I, just to spite one guy, he woke me up at 7:45, and I was reading, and I kept him on the phone for 20 minutes, and then he hung up on me.
That's hilarious.
I had nothing to do, so he asked me this question and that question. Then he hung up on me. I've already had Medicare through the university, so all they're trying to sell me is worthless. All right.
That's hilarious. Wish we could like spam their phone lines back.
All right, let's throw the small signal. If you can don't throw small signal, you're in business. Right, big guy?
Yeah, I think I got you.
Base, collector, emitter. Let's make some decisions now. From base to emitter, we have R pi.
Yep.
R pi 1. Okay, this is a PNP. The current goes which direction? Up. Beta IB, IB. And the emitter is sitting where? It's shorted out, right? Ground on top there with that capacitor. What goes in here?
2.4K.
2.4K. And this is 1.2K. You see the beautiful numbers? See the voltage division here? This 1/2? Yeah. Not 1/2, it's 1/3. All right?
I had a question too. We were working on one of the problems like yesterday, and when you're doing the MOSFETs, like we broke down to the IDS, and like when you cancel out it was the amps, milliamps over V squared. Like it only cancels out one of those volt units.
Yeah.
Where's that other unit go?
Where's the other one?
There's another 1 over V at the bottom. When you cancel them out, when you set the IDS.
I don't remember what we're talking about.
It's inductance, it's milliamps over volts. So
Yeah, when you're doing the MOSFET, you
Yeah.
set the IDS equal to each other?
Yeah, it's 1 over ohm, so it's inductance.
Okay.
Did he answer you?
Yeah.
All right. Now, what is tied on the collector? 2K, right? 2K to ground, and this will give you the gate. See where the gate is? There's the gate. There's a source, so this is VGS. And here is the current source to the source. Let's take a look at the source. The source is what? Ground. See on top, the arrow? So there's a ground, there's ground, and this is what? P channel, which way the direction is? I just made an error. This is G sub M, VSG, and here's the mistake. And this would be VSG. Right? Okay, what is tied on its drain? 2K. To ground. Now, there gives you the base of 2. The base of 2 is emitter follower, you can see that. No, it's not. Here's R by 2. Where's the emitter go? Ground again. And here is beta IB. What tied on the output?
4K.
4K in parallel with 4K.
Oh, 4K plan for.
Here's the out. Once we draw that, it's easy to calculate the chain, right? Which is the first one? What's on the first one?
VR over beta, I think. So.
Huh?
V out of
VR
Let's
over
call
IB.
it 2,
IB2.
Oh, you're saying minus,
right? The out over IB2. What's the second one? Here's IB2.
Or VG or GS2. VGS2.
IB2
Or
to
VSG2, no.
VSG,
VSG2.
VSG2. VSG, man, we only have one.
Yeah.
This is 2. What's the third one?
VSG2 to beta IB1 or IB1.
What's the fourth one?
IB1 to BI.
Yeah, but to make it a little easier, call this as VB. Remember, you have a voltage division here.
Right.
So there will be IB1 over VB, right? What's the last one?
VB over BN.
VB over VN. Correct? I just inserted a little extra. That's V out over Vn. Okay, now, V out over IB2 minus beta 2K. IB2 to VGS is minus G sub M.
positive.
No.
Oh,
2K divided by 2K plus R by 2.
Will it be positive GM? Because the current's going up.
Right, positive. And this is R by 2 is 2.5K, right? This is R by 2. Okay, where am I? VSG over IB1, what is it?
VSG or
oh, it's just beta 2K.
Yeah.
Positive.
Beta 2K.
Beta times 2K,
Oh, mine.
okay, so this, so what is it, plus or minus?
Minus.
Minus, this is a polarity,
VSG,
minus.
yeah.
It's minus beta times 2K, remember the units. The unit tells you what it is, ohms. What is the fourth one? Minus 1 over R by 1, right? And what's the last one?
1.
Huh? V out over Vn, or VB over Vn,
Just
1.
oh,
not 1.
Oh.
What is it?
Oh,
It's r pi 1 in parallel with 2.4k divided by r pi 1 in parallel with 2.4k divided by r pi 1 in parallel with 2.4k plus 1.2k. Right? Numbers. You want to put the numbers? Let's put the numbers.
100.
The minus beta, and bring this beta, it'll become beta squared. Let's get the minuses first. Minus times minus times minus, so it's overall minus. 2k times g sub m will give me, what's g sub m calculated? 1, right?
1 million.
1 milliamp per volt.
So times 2k, it'll be 1. I mean, it'll be 2. Here it'll be 2 over 4.5. That's this number. And here is 2 divided by 2.5. This is 2.5, this is 2. And this is 2.5 in parallel with 2.4 is approximately 1.2. This is approximation. And this is a 1.2 plus 1.2. 2.4, so this is really a half.
Yeah.
Okay, so here's your numbers. This is 10 to the 4. 1, 2, 3, 8 times 1.2, 9.6 divided by 4.5 times 2.5 times 2.4. I could have eliminated this, put 1/2 difference.
It's negative 3555.5.
I think that's the answer. 555.
Yep. 0.5 volts.
So 2 stage, 3 stage, nothing. Once you master this stuff, it's easy. You feel more comfortable now? Have you learned a lot in this course?
yeah.
I think so. Still kind of taking it in.
You're gonna make 100 on the test? I wish everybody makes 100. I will be, would that be nice?
I would love to, but.
You can make it so you get 100.
I was just happy because I was able to.
That would be nice.
On the quiz today, so.
Oh, you got the quiz. Hey, by the way, the quiz today we did in class, right?
Yep.
I took it right out of the notes. I didn't have time to make a new one.
Nice.
So I figured it out. Some people make mistakes.
I knew those numbers look familiar from like a textbook.
I didn't ask you for the gain. The gain is a little bit more.
And Tuesday's quiz, we expect something similar? You said?
Tuesday's quiz, we're going to be calculating the gain. But to calculate the gain, you must do the DC analysis, right? We will skip DC and AC load line on Tuesday's quiz. We already did that today.
Oh.
And that's it. Your class, this class, is the two problems I did, I haven't done in the other class. So you're ahead. On Tuesday, you can take the quiz and go home, unless you have questions.
Oh, so you're gonna teach them first and
If
then
you have
give them
questions, I'll be
quiz?
glad to sit down and, the first 10, 15 minutes, I'll ask you if you have any questions. If you, then after that, we'll take the quiz. I'll give you the quiz and you're done for the course. Not done, you still owe me
Final.
5%.
Yeah.
What's the final again?
But I'll give you two problems in the other class. Pass the word to peoples in this class. So if they missed this period today, they could go to next week in the morning and see these problems. So that I'll be lecturing the same thing. What we just did. All right, it's been fun. I hope you do well in electronics too, or beyond that too, if you don't go into electronics too.
Excellent.
and I gave you a test that shimmy and graded.
Thank you.
And I did put the 1.2 multiplier on it.
Oh, wow, thank you.
Okay, I don't wanna leave you on the call. All right?
All right.
Any questions?
No.
Did everybody get their stuff checked out that need to be checked out today?
Yeah, it's
Yeah.
You still checking?